All right, if you're an ML developer, you know this feeling. You've been grinding away in a Jupyter notebook for weeks. You've engineered the perfect features, you've tuned all the hyperparameters, and bam, you have a model that's just beautiful. But now what? How do you get that masterpiece out of the notebook and into the real world where it can actually do something? Well, that huge gap between development and production is exactly where MLOps lives. And today, we're going to cover the 10 essential Python libraries you absolutely need to know to bridge it. So here's our game plan. We're going to walk through the 5 key stages of any solid MLOps lifecycle. First, we'll get a handle on the chaos of experiments. Then we'll build an automated factory for our models, serve them up to the world, keep a close eye on them for any trouble, and finally, we'll see how all these pieces click together to form one seriously powerful stack.
Okay, first things first. We've got to tackle the single most fundamental challenge in any serious machine learning project: reproducibility. I mean, without a single source of truth for our experiments, our data, and our models, we're basically just flying blind. It's chaos.
And seriously, think about it. For just one model, you've probably got hundreds, maybe thousands of different runs with different parameters. And on top of that, your datasets and the models themselves can be huge. We're talking gigabytes. There's no way you're putting that in Git. This is the first major hurdle, and luckily, our first 2 libraries have us covered.
So the first piece of this puzzle is just tracking your experiments. This means logging everything about a training run: the exact code you used, the parameters, the performance metrics, so you can always trace a model all the way back to its origins. And for this, the hands-down winner, the industry standard, is MLflow. It's open source, it works with any framework, and it's built to manage the whole ML lifecycle. And what's wild is how easy it is to get started. Just look at this. You wrap your code in a with MLO.startRun block, and then with a few simple commands, you're logging everything: your learning rate, your final accuracy, even the scikit-learn model object itself. It's such a lightweight way to make every single run totally traceable and easy to compare. It cleans up your workflow like you wouldn't believe. Okay, so logging parameters is great, but that's only half the story, right? What about the actual data the model was trained on, or that massive model file it produced? That's exactly where our second library, DVC, or Data Version Control, comes into play. Think of it as a companion to Git, specifically designed to handle all the big stuff that Git just can't. And the beauty of it is the workflow feels just like Git, so it's super intuitive. You use DVC add to tell it to track a big data file. DVC then cleverly stores a pointer in Git, while the actual file goes to a remote storage location, like S3. Then you use DVC run to define your pipeline steps, linking code versions to data versions. It creates this perfect, unbreakable audit trail from your raw data all the way to your final model.
So now we can track our experiments and version all our data. Awesome. But what about chaining all those steps together? You know, the pre-processing, the training, the evaluation. How do you make that a single automated workflow? Well, that question leads us perfectly into our next set of tools.
So this is where we level up. We're moving away from running individual one-off scripts, and we're starting to build that automated ML factory we talked about. This is the domain of workflow orchestrators, and their job is to manage the complex dance of running tasks in the right order.
And here are the 3 heavyweights in the space. Honestly, your choice here really depends on your environment. If you live and breathe Kubernetes, Kubeflow is the native, obvious choice. If you're building data science workflows that are very human in the loop, especially on AWS, MLflow, which came out of Netflix, is amazing. And for a super robust, general-purpose scheduler that's been battle-tested for years, Airflow is the undisputed king.
Now, at first glance, the syntax looks totally different, right? Airflow has these cool bit shift operators. MetaFlow uses a self.next call inside a class method, and Kubeflow uses an after method. But they're all doing the exact same thing. They're defining tasks and saying, hey, this task has to run after that one. They're all building what we call a directed acyclic graph, or a DAG. And that DAG is the blueprint for our entire ML factory.
Okay, so our factory is humming. It's churning out these perfect, validated, versioned models. But a model sitting on a server is pretty useless, isn't it? We need to get it in front of other applications so they can actually use it. And that brings us to the crucial world of model serving.
And this brings us to our biggest category yet, with 4 incredible libraries all laser-focused on one thing: taking your trained model and exposing it as a fast, scalable, and super reliable API endpoint. Let's break down when you'd reach for each one.
For these first two, it really all comes down to scale. If you just need a straightforward, ridiculously fast API for your model, FastAPI is a phenomenal choice. It's famous for its raw speed and the way it automatically gives you interactive API docs. But if you know you need to handle some serious traffic and scale across a whole cluster of machines, Ray, and its Ray-serve component, was literally built from the ground up for that kind of distributed power.
Now, if you're playing in the big leagues, especially on Kubernetes, you might need more advanced deployment strategies. That's where Selden Core shines. It's a powerhouse that lets you easily do complex things like A/B testing or canary rollouts right out of the box. And finally, there's Bento ML, which tackles a slightly different but related problem. It helps you create a standardized package, a bento, that bundles your model, its code, and all its dependencies together for super easy, reproducible deployments anywhere.
Now, here's a secret that a lot of people unfortunately learn the hard way. Deploying your model is not the finish line. Not even close. In fact, it's really just the beginning. The real world is messy, and models, well, they have this nasty habit of getting worse over time as the data they see in production starts to drift away from what they were trained on. We have to watch them.
And this performance decay is almost always caused by a problem we call data drift. It's what happens when the live production data your model sees day to day just doesn't look like the training data anymore. It's like a silent killer of model accuracy. And to catch it before it does real damage, you need a specialized monitoring tool. And this is where our final library, Evidently, is an absolute lifesaver. It makes this whole process so much easier. You just create a report, tell it what you want to check for, like a data drift table, and then you run it. You give it your current data, that's the live stuff, and a reference data set, which is usually your original training data. It then automatically spits out these beautiful, interactive reports that show you exactly where and how your data is drifting, so you can retrain your model before anyone even notices a problem.
Okay, let's zoom all the way out. We've gone on a huge journey here, all the way from a chaotic notebook to a fully automated, versioned, served, and monitored production system. Now let's put all 10 libraries back on one slide and see what our complete MLOps stack looks like.
And there you have it, the whole stack, laid out. Each layer is tackling a critical part of the lifecycle. You've got DVC and MLflow giving you that solid, reproducible foundation. You've got an orchestrator like Airflow or Kubeflow to put it all on autopilot. You've got your serving layer to actually deliver value to users. And you've got Evidently standing guard to make sure everything stays healthy. This isn't just a random list of tools. This is a blueprint for building professional, modern, and reliable ML systems.
By getting a handle on these tools, you're not just a model builder anymore. You're becoming an MLOps engineer who can build scalable, dependable systems that actually last. You have the complete toolkit to take any idea from a notebook all the way to production and, just as importantly, keep it running strong. The only real question left is, what are you going to build with it?